Space is vast, bigger than we can imagine, but it's not empty, it's filled with stuff. This stuff includes everything from tiny particles of dust to massive celestial bodies. Among these, some of the most fascinating and potentially dangerous objects are asteroids. Some of that stuff is big, really big, we call them asteroids. These rocky remnants from the early solar system can vary greatly in size, from small boulders to giant rocks that are hundreds of kilometers in diameter. Big rocks hurtling through space. They travel at incredible speeds, sometimes tens of kilometers per second. Their paths are influenced by the gravitational pull of planets and other celestial bodies, making their trajectories unpredictable. Sometimes these asteroids come close to Earth, sometimes they hit. When they do, the results can be catastrophic. The impact releases immense energy, equivalent to thousands of nuclear bombs, causing widespread destruction. Most are small and burn up in the atmosphere. These are what we see as shooting stars. They create beautiful light shows in the night sky, harmlessly disintegrating before they reach the ground. But sometimes, just sometimes, a big one gets through. These impacts are rare. However, when they do occur, they can have devastating consequences, altering the course of life on Earth. But when they happen, they can be devastating. Just ask the dinosaurs. The asteroid that struck Earth 66 million years ago caused a mass extinction, wiping out nearly 75% of all species, including the dinosaurs. We need to be prepared. Scientists around the world are constantly monitoring the skies, tracking the movements of these space rocks. They use powerful telescopes and advanced technology to detect potential threats. We need to find these asteroids. Early detection is crucial. The sooner we know about a potential impact, the more time we have to prepare and possibly prevent a disaster. We need to figure out how to stop them. Various strategies are being explored, from deflecting the asteroid with a spacecraft to using nuclear explosions to alter its course. These methods are still in the experimental stage, but they offer hope for the future. The fate of humanity could depend on it. Our ability to detect and deflect these space rocks could one day save our planet from a catastrophic event. It's a challenge that requires global cooperation, scientific innovation, and unwavering vigilance. 66 million years ago, a giant asteroid slammed into Earth. It wiped out the dinosaurs. Gone! The impact changed the climate, causing widespread destruction, but that's not all. Smaller impacts happen more often. In 1908, an asteroid exploded over Siberia, flattening trees over 800 square miles. That's bigger than New York City. More recently, in 2013, a meteor exploded over Chelyabinsk, Russia. The shockwave injured over 1,000 people. These events remind us the threat is real. Fortunately, we're not sitting ducks. Scientists around the world are constantly searching the skies for asteroids. They use powerful telescopes to scan the darkness, looking for anything unusual. These telescopes are incredible. They can spot a refrigerator-sized asteroid millions of miles away. That's like seeing a fly on the moon. Once we find an asteroid, we track its path. We calculate its trajectory and see if it poses a threat to Earth. It's like cosmic detective work. Finding asteroids is hard work. It's like finding a needle in a haystack. Space is big, really big, and asteroids are dark and hard to see. To find these hidden dangers, scientists use special telescopes. These telescopes look for heat, not light. Asteroids reflect sunlight, which makes them warm. By detecting this heat, we can find asteroids hiding in the darkness. This is important because the sooner we find a dangerous asteroid, the more time we have to do something about it. Section 5. Can we move a mountain in space? So, we found a big one. An asteroid heading straight for Earth. What do? Hollywood loves to blow them up, but there's a better way. It's called deflection. The idea is simple. Slightly change the asteroid's path. Even a tiny nudge can make a big difference over long distances. It's like steering a car. A small turn of the wheel can change your destination. But how do you move a mountain in space? That's the challenge. Section 6. Nudging the threat away. One idea is to use a spacecraft as a cosmic bulldozer. Imagine a spacecraft designed specifically to intercept an asteroid on a collision course with Earth. This spacecraft would travel millions of miles through the void of space, navigating the vast distances and harsh conditions to reach its target. Once it arrives, it would position itself to crash directly into the asteroid, Using its own mass and velocity to nudge the asteroid off its deadly trajectory, we crash it into the asteroid, pushing it off course. The impact would transfer kinetic energy to the asteroid, altering its path just enough to avoid a catastrophic collision with Earth. This method, known as a kinetic impactor, relies on precise calculations and timing to ensure success. Sounds crazy, but it could work. Scientists and engineers are already working on prototypes and simulations to test this concept. The idea is to develop a reliable and effective way to protect our planet from potential asteroid impacts. Another idea is to use gravity. This method, known as a gravity tractor, involves sending a spacecraft to fly alongside the asteroid. By maintaining a consistent distance and position, the spacecraft's gravitational pull would gradually alter the asteroid's trajectory over time. Every object in space has gravity. Even small objects like spacecraft exert a gravitational force, albeit a weak one. By leveraging this force, we can create a subtle but continuous tug on the asteroid, slowly changing its path. We could send a spacecraft to orbit the asteroid. The spacecraft would need to stay in close proximity to the asteroid for an extended period, carefully adjusting its position to maximize the gravitational effect. The spacecraft's gravity, though weak, could slowly tug the asteroid off course. This method requires patience and precision, as the changes in the asteroid's trajectory would be gradual and take time to become noticeable. It's like playing a game of cosmic billiards. Each move must be carefully planned and executed to achieve the desired outcome. The stakes are high, but the potential benefits are enormous. These methods are still in the early stages of development, but they offer hope. With continued research and innovation, we may one day have the tools and technology needed to protect our planet from the threat of asteroid impacts. The future of planetary defense is bright, and the possibilities are as vast as the cosmos itself. Section 7. Blowing it to smithereens. Blowing up an asteroid might seem like a good idea, but it's not. The concept of destroying an asteroid with a massive explosion is often depicted in movies and TV shows. It seems like a straightforward solution to a potentially catastrophic problem. However, the reality is far more complex and dangerous. When an asteroid is blown apart, it doesn't just disappear. Instead, it breaks into countless smaller fragments. These fragments, now scattered in space, can still pose a significant threat. Imagine turning a single large bullet into a cloud of buckshot. Each piece of debris can still cause immense damage, especially if it heads towards Earth. It's like turning a bullet into buckshot. It's still deadly. The smaller pieces might be harder to track and could spread out over a wider area, increasing the chances of impact with satellites, space stations, or even Earth itself. The danger doesn't diminish, it multiplies. However, a targeted nuclear explosion could be a last resort. Scientists have considered the possibility of using a nuclear device to alter the course of an asteroid. This method wouldn't aim to destroy the asteroid completely, but to change its trajectory enough to avoid a collision with Earth. The idea is to vaporize part of the asteroid's surface. By doing so, the explosion would create a forceful jet of gas. This gas would act like a rocket engine, providing a thrust that could push the asteroid off its collision course. This would create a jet of gas, acting like a rocket engine, pushing the asteroid off course. The process requires precise calculations and timing. The explosion must be powerful enough to create the necessary thrust, but not so powerful that it shatters the asteroid into dangerous fragments. It's a risky move, but it might be our only option if time is short. In scenarios where an asteroid is detected too late for other deflection methods, a nuclear explosion might be the only viable solution. The stakes are incredibly high and the margin for error is slim, but with careful planning and execution, it could be the key to saving our planet from a devastating impact. Section 8. Space, the final frontier, for survival. The threat of asteroid impacts is real, but it's not insurmountable. We have the technology to find these threats and develop ways to protect ourselves, but it takes time, resources, and international cooperation. We need to invest in space exploration and research. We need to work together to solve this global challenge. After all, we have one planet, let's protect it. Section 9. Investing in our future. Space is not just about exploring the unknown. It's about understanding our place in the universe. It's about pushing the boundaries of science and technology. Investing in space programs isn't just about discovering new worlds or searching for life beyond Earth. It's about protecting our own world. It's about ensuring the survival of our species. The future of humanity may depend on it. Let's make sure we're ready for whatever the cosmos throws our way.